Hello everyone, this is Dr. Marrero from Math Topics. Welcome to this channel about mathematics instruction, mathematics learning, mathematics teaching. Today I will continue with the series about how do I teach math, how do I learn math. If you are interested in some of those videos, visit the channel and watch the playlist. Today I want to talk about inverse operations. I am a strong believer that when you create the foundations in mathematics learning, when you're teaching, if you are a teacher or if you are a learner by yourself, when you create that powerful foundation in terms of vocabulary, in terms of definitions, in terms of conceptual ideas surrounding the subject, the mathematics, then you have a better outcome in your learning experience with mathematics. I know as a teacher for more than 20 plus years that the students in majority, they struggle in math not only because it's a difficult subject, it's because they don't have that foundation. They don't have that conceptual foundations about the topic. And they are basically robots that they follow a procedure without thinking what is behind each step in mathematics. Procedural mathematics is after conceptual mathematics. This is really important in teaching and learning. So if you're going to solve an equation, let's say that you want to solve an equation, and you follow a series of steps, that is a procedure. But we have to explain before that, and we have to make that foundation before the procedure. Why do we do what we do? And this is the beginning of a change in a student's perception of the mathematics, and it's also a change in a student's engagement and motivation for mathematics. We experience as a teacher, all the teachers, mathematics teachers, a lack of motivation and a lack of engagement in classes because the long procedures. Today, I'm not going to solve any math problems. I just want to talk about the inverse operation. This is one of the topics that amaze me more because it's present throughout all the mathematics fields. So inverse operations are powerful. They are, if you understand them, you can understand many of the most difficult areas of the mathematics. And the question that you see, or the expression that you see right there on the board, that is an integral, is a function g of x, which is an integral 3 to x, okay, of that quadratic expression t squared minus 5t minus 14 is an example that I just brought here today that contain what I'm talking about and what is the idea of the video today, inverse operation. So for that simple expression, I can ask you multiple questions, but I want to make the difference between what you see and what the question is about. Remember that in testing, in assessment, the main object, in this case, this is the main object, that function g of x defined as an integral, can be everything. So I can ask you, for example, can you find the inflection points of the function g of x? And as soon as you see the integrals of students that knows calculus, or you, the viewer that knows calculus, it's going to be kind of, shocking when you see the integral and somebody's asking you about the points of inflection, okay? Because the point of inflections are procedures. The students learn or memorize procedures, to find the point of inflections. If you are interested in point of inflections, I have a recent video about the point of inflections. The students know that they need to find the derivative of the function. The student knows that they need to equal the derivative function to 0 and find the zeros of the derivative, and those are the possible candidates. And then they can start evaluating the surrounding of those points. This is the procedure to find the inflection points. And also, when the function is concave up or concave down, is the same procedure, and you use the second derivative, and then you can evaluate the second derivative. You can equal the second derivative to 0. And I can spend the entire video explaining the procedure. Your question as a teacher or as a math learner is, why am I doing this? This entire procedure. And this is when conceptual mathematics comes to play. But because if you don't have a foundation about what inverse operation is, for example, and this is the topic of the video, you get lost in the question, or you get lost learning the content. For example, that function right there, t squared, the integral of 3 to x of t squared minus 5t minus 14, and I want to find the point of inflection. But I know that the integral is the inverse operation of differentiation. That's it. Because I know that that function that you see inside right here, and let me use my highlighted, that function that you see here, or that expression that you see here, represents the derivative of a function. Represents the derivative. And when you find the integration, you return to the original function. So basically, this is the derivative of some function. Because if you are finding the integral, it's because this expression is the derivative. Because the integration is the inverse operation of differentiation. So you have let's put it clear. You have a function f, and you find the derivative of the function f, and you generate another function, f prime, that we denote f prime. The way to move back to the original function f, okay, let's say this is the capital letter f, original function, you find the derivative, and you get the lowercase f prime, which is the derivative of that function. If you want to go back, you have to find the integral. Integration. So integration, and the word itself implicitly is telling you, you have to go back. And this is the power of inverse operation. And you have that across all the mathematics, starting with the 4 basic operations, starting with addition and subtraction, multiplication and division. And instead of doing only procedures, we have to start talking about, in elementary school, in any introduction, we have to start talking about inverse operations. 5 plus 4, 9. How can I return back to one of those elements? Okay, I do subtraction of 5 times 4, 20. How can I go back dividing? And when I square a number, how can I go from 3 to the second power, which is 9, to back? I have to find the square root of the number. So the inverse operations are present across the mathematics. When you drive, you have the inverse operations right there. So you have the driving shift, you have the reversal shift, you have right there the number line. You have right there the number line. So if you shift to D, which is driving, you start moving forward. If you shift to R, you start reversing. And if you shift to neutral, is kind of a 0. on the number line. And this is the way to teach mathematics, or the way I like to teach mathematics. You have your own way, and you're more than welcome to write your comments below and say, I do it this way. This is a community of learners. I'm just sharing my ideas. So driving, reversal, neutral, and the parking lot. And you can explain with that. You can explain even calculus. Okay? You can explain calculus because when you move forward, you are moving through positions, and the average of those positions is the velocity. Okay, the average of those positions. And then the average of those velocities is the acceleration, which is the second derivative. How can I go back? Always in mathematics, we have the ability and the power and the beauty of going back. So addition, subtraction, multiplication, division, squaring a number, power 2, square root of the number. Differentiation, integration. So when you are at high level classes like calculus, and you see that expression right there, immediately your eyes are going to this structure here, or this symbol here, that is telling you you are going to go back to the original function. So you know that this function right here is no more than the original function that at some point you differentiated to get this. And at some point you want to go back to the original. So this is the derivative of something. And the integration allows you to return to that something. This is the power of inverse operation. And this is my invitation today, that you come up with examples of inverse operations. And how can you treat inverse operations in a math class, or learning math, or teaching math? And that power, if you can disseminate those ideas in a classroom, if you can engage the students in those ideas of inverse operations, you are empowering your students to understand mathematics. You are empowering your students to be successful in a subject that usually the students struggle with. And that day, we are going to start changing. We are going to start changing the learning of mathematics. That this is the purpose of this channel, to share with you, to create a community of learners, people that likes and love mathematics, and people that they want you, the viewer, see the mathematics from a different view. So that's why your comments are welcome, and I appreciate all of them. Inverse operations. How inverse operations can empower our learning and can empower our teaching, and always expressing in every aspect of the mathematics, and you can connect it. The magic word in learning mathematics is connection. You can connect inverse operations since the students is in elementary school, or when they start counting. A simple counting. 1, 2, 3, 4 for a little boy, a little girl, 5, 4 years old. They start counting. You can start talking about inverse operations. Pick 5, subtract 3. You get 2. I want to go back to 5. Retake the 3. And that retake, that process of opposite directions will help the students to understand not only counting, not only arithmetic, not only solving equations, because when you have x plus 5 equals 7, that kid, that little one that start learning mathematics that way, you have 5 counts and you subtract 3. How can you go back to 5? So you return the 3. So you're adding 3 after subtracting 3. It's amazing. because that little kid will be facing the first linear equation, x plus 5 equals 7 or x plus 4 equals 7, and in his or her mind they're going to say, okay, that x now is my I don't know, my 3 plus 4 equals 7. And inverse operation is the main player, is the main player of that learning process that is occurring right there in that student mind. And then when you complicate that to two-step equations, 3x plus 1 equals 7, it's going to do the same, because the student knows that I need that x, and to do that x, I had to work with opposite directions. I have to work with opposite directions. If I'm adding, I need to subtract. If I'm multiplying, I need to divide. And taking all the learning through the process of inverse operation is going to help a lot. It's not everything, but it's going to help a lot. I hope you like this brief video that I want to share with you. As a teacher, I experience this every day. Tell me if you as a teacher experience the same, or as a parent you experience the same, that you are at some point that you're lost, and that you try to explain and your child or your students, they're not learning the way you like it. We have to change the way to teach. This is the prompt to change the way that we teach, because the brain understands logic and reasoning. If we try to feed our brain with something that is not logical and something that is not reasonable, the brain is going to stop, and the brains won't develop. Okay, this is really important to understand. If we teach one way and we do not receive back the best results, it's because we need to change the teaching, and we need to change the learning. So this is the invitation today. The invitation today is, how can we teach inverse operation across the curriculum from pre-K all the way to college, all the way to that question that you see there. And I can ask you, find the inflection points, and you can say, when that student see that expression, the students understand that t squared minus 5t minus 14 is a function that was the result of a differentiation of another function. Okay, and they can start working with that particular derivative, and they can equal that particular function to 0. They don't need to find the integration, because if they want to find the inflection points, they need the derivative. They already have it. This is the knowledge of inverse operation, and this is conceptual mathematics. I hope you like the video, and I hope that you share the video. See you in the next one, and thank you for watching.